Hello everyone, in this lecture we will study that how much phase margin is adequate. So we have examined the closed loop frequency response for different phase margin under this heading. So let us take phase margin Pm, that is equals to 45 degree at the gain crossover frequency where phase angle beta h omega 1 is equals to minus 135 degree, and the magnitude at omega 1 is equals to 1, which yields y upon x. The closed loop transfer function will become h j omega 1 upon 1 plus 1 exponent of minus j 135 degree, which will become h j omega 1 upon 0.29 minus 0.71 j. So it follows that when we solve the above equation, we'll get the magnitude of y by x will become 1.3 upon beta. So the frequency response of the feedback system suffers from 30% peak at W equals to W1. So it can be shown that over here that at the gain crossover frequency the phase angle is minus 135 degree, as we have taken the phase margin to be equals to 45 degree. So there is a slight peak in the frequency response of this system, having a peak of 1.3 upon beta. Okay, so there is a little ringing. Now we have observed the closed loop time response for 45 degree, 60 degree and 90 degree phase margin. We observe that for a phase margin of 60 degree, the closed loop transfer gain will become 1 by beta, which have a negligible frequency peaking. This typically means that the step response of the feedback system exhibit very little ringing, providing very fast settling time. And for greater phase margin, the system is more stable, but the time response slows down. So this phase margin of 60 degrees is typically considered the optimum value. Okay, the concept of phase margin is well suited to the design of circuit that process small signal. In practice, the large signal step response of feedback amplifier does not follow the above illustration. And because of the non-linear behavior resulting from the large excursion in the bias voltage and current of the amplifier. And such excursion in fact cause the pole and zero frequency to vary during the transient, which lead to a complicated time response. Thus, for large signal application, time domain simulation of the closed loop system prove more relevant and useful than small signal AC computation of open loop amplifier. Okay, so, an example of a feedback circuit exhibiting a reasonable phase margin but poor settling behavior. Consider the unity gain amplifier, which is shown over here, where the aspect ratio of all transistors is assumed to be 50 micrometer upon 0.6 micrometer. So this is the example of a feedback circuit which exhibits a reasonable phase margin but having a poor settling behavior. And with the choice of the device dimension, bias current and the capacitor value shown over here, we have taken the same values we have taken as spice, and the spice yields a phase margin of approx 65 degree and a unity gain frequency of 150 MHz. The large signal step response, however, suffers from significant ringing, which is shown over here. Okay, so this is the example where we have an adequate phase margin but having a poor settling behavior. And this is the example of a feedback circuit. Okay, so this is all in this lecture of how much phase margin is adequate. In the next lecture, we will study about basic frequency compensation. Thank you.